Hello friends, today I am going to explain the working of AM super heterodyne receiver. This is just an overlook of the receiver, but the block diagram of an AM super heterodyne receiver consists of receiving antenna, RF amplifier, mixer, IF amplifier, detector cum AJC, AF amplifier, power amplifier, loudspeaker and a local oscillator, wherein RF amplifier, mixer and local oscillators tuning circuits are ganged together. That means a ganged capacitor is used in these three tuning circuits. This is a RF signal, IF signal, amplified signal, audio signal, amplified audio signal. Let us see the working of each block of this AM super heterodyne receiver. Receiving antenna receives electromagnetic waves from different channels and converts that EM waves into electrical signals. Receiving signals are as many as number of channels. Hence, RF amplifier should able to identify the weakest or the strongest signal but the desired signal. Hence, it consists of RF tuner, which is nothing but a parallel LC circuit, followed by cascaded RF amplifier stages. The parallel LC circuit is also known as rejector circuit. It is used to select a particular frequency among all the RF signals present at the antenna. After the selection, the signal should be amplified because the receiver is far from the transmitter. While transmitting, the RF carrier would have lost their strength. So, we use a cascaded amplifier stages unless until it is reached to our desired strength. This stage increases the sensitivity and the signal to noise ratio of the signal. The RF amplifier stages has a range of frequency from 550 kHz to 1650 kHz. This local oscillator is normally we use Colpitts or crystal oscillator because they provide a highly stabilized waveforms with a high frequency. The range of local oscillator frequency is from 1005 kHz to 2105 kHz. It is noted that the difference between the local oscillator minus the RF amplifier stage is always maintained at 455 kHz. You can check in here, 1005 minus 550 is a 455 kHz. Similarly, 2105 minus 1650 kHz is again a 455 kHz. That means for AM receivers, the IF signal is kept at 455 kHz. The receiving antenna, after giving the signal, RF amplifier amplifies the signal, that is called as signal frequency fed to mixer. Along with the signal frequency, local oscillators frequency FO is given to a mixer. Mixer does heterodyne action. That is why the name super heterodyne in the receiver. Heterodyne is a process where all the high frequency components are beaten or brought down to an intermediate frequency level. Mixer does this heterodyne action. Actually, the output of the mixer is the sum of these two and the difference of these two signals. But at the end we use filters such that they filters the sum of the signal and provides only the difference. Thus, the mixer output is F0 minus Fs. Always we keep local oscillator frequency higher than the RF amplifier or received signal. Now, local oscillator stage and mixer stage along with RF amplifiers are having a common variable capacitor which is called as ganged capacitor. This ganged capacitor actually has two sets of plates. One is a fixed plate and another is a variable plate. When we tune this ganged capacitor, the capacitance of this is varied, but it is given to the three circuits. All the tuning circuits are varied in the same proportion. Hence, whatever may be the frequency range, 550 to 1650, between this and between this, whatever the frequency we select between local oscillator and RF amplifier, the mixer is able to provide only for 55 kHz at the output. Next, the output of this mixer is given to IF amplifier as the frequency belongs to IF range. This IF amplifier provides high selectivity and stability. Overall gain of the receiver is increased. Better adjacent rejection ratio is also provided. The strength of the RF signal after beating down would have been decreased. Hence, we use IF amplifier stages to increase the strength of the signal. Then given to a detector circuit. Detector or detection is nothing but it extracts the original signal from the modulated signal. This is done by separating high frequency and audio frequency signal. To do this, detector does mainly two functions. That is, one is rectification, which removes the negative half cycle of the amplitude modulated wave. Next is a filter circuit, which bypasses high frequency signals to ground and allows only audio frequency signals at the output. A portion of detector is also given to a clipper circuit, which is nothing but automatic gain control. This is necessary and a very important aspect of super heterodyne receiver. We will see this little later. Now, the output of the detector is given to audio frequency amplifiers. As detector detects or extracts the audio frequency, the strength of this audio frequency should be increased before giving it to a loudspeaker. So initially we use audio frequency amplifiers, which are called as pre-amplifier stages, wherein the strength of the audio signal is sufficiently increased. Once it is sufficiently increased, it is given to power amplifiers, voltage to power amplifiers, wherein the power of the signal is also increased. Also, this provides the impedance match between audio frequency and the loudspeaker, and the strength of the signal should be sufficiently high to give it to a loudspeaker. Once the signal is given to a loudspeaker, loudspeaker converts the electrical signals into the respective sound waves. Usually, power amplifier is a push-pull power amplifier whose bandwidth is fixed to 5 kHz. And hence, the output of the loudspeaker will be the signal which has been transmitted, the information which has been transmitted. This is how AM super heterodyne receiver works. Now let us see what is the importance of this AGC. AGC is also called as automatic gain control or automatic voltage control. Normally receivers means radios or mobile phones which has FM radios, and we have come across many times when we are using these things, when we move this receiver or when we tune this receiver from one station to another station, while process is done, tuning is done, the signal strength may vary. Or when the receiver is moved from one place to another, again there are chances that the signal strength may vary. Also, sometimes due to atmospheric conditions, the strength of the received signal will not be same. Hence, the received signal strength should be maintained constant. Otherwise, if it is high, overload or a distortion occurs or a blasting sound occurs at the loudspeaker. If it is low, then the signal will not be clear at the loudspeaker. So automatic gain control is very necessary. You can see at this diagram, the output of AGC is fed back to RF amplifiers, mixer and IF amplifier stages. Let us see this in detail. The variation in the signal strength causes either increase or decrease in the strength of the output signal. Hence, gain of the receiver has to be adjusted every time. But this is not possible to do by manually. Hence, automatic gain control is necessary. What is this AGC circuit consists of? It is a very simple clipper circuit whose input is from detector. It takes the input from the detector, filters it or converts it into a DC voltage. This DC voltage is fed back to IF amplifier, mixers and RF amplifier stages. The amplitude of this DC voltage is proportional to the amplitude of the received signal, but is inversely proportional to the gain of the amplifier stages. This is the major twist in this AGC. That is, if the received signal strength is very high, then DC voltage produced is also high because it is proportional to the received signal strength. But this is given as a feedback, and amplifiers feedbacks are negative feedbacks. Because of this negative feedback, it is inversely proportional to the gain. So a high voltage is given which reduces the gain of the amplifier stages. Thus, overall distortion can be avoided. If the received signal is very weak, then a very small DC voltage is produced, which in turn increases the gain of these stages, thereby the sufficient gain is provided. Thus, automatic gain control circuit controls the receiver's gain automatically, and this is very important to avoid the distortion. If you like this video, please press like button, share, comment. Also, don't forget to subscribe. Thank you one and all for watching this video.